Hello, my name is John Austin, product marketer with Microchip Technologies Analog Division. This video will provide an overview of the MCP9600 evaluation board. The MCP9600 is a fully integrated thermocouple to temperature converter. The MCP9600 integrates the precision instrumentation, the cold junction compensation, the analog to digital conversion, and the math engine and firmware to support 8 standard thermocouple types. This is a true plug-and-play solution. To start, I will give a brief overview of what a thermocouple is. A thermocouple consists of 2 dissimilar wires, joined at one end. The joined end is called the hot junction, and is the temperature that is being measured. And the opened end is the cold junction. The voltage potential is proportional to the temperature, and is known as the Seebeck effect. The voltage change is in the range of tens of microvolts per degree Celsius. This requires precision instrumentation to accurately calculate the corresponding temperature at the hot junction. For the discrete solution, this requires many areas of design expertise. First, precision instrumentation circuitry is needed to accurately measure the microvolt level changes in the voltage at the cold junction. The voltage measured at the cold junction must then be converted from the analog domain to the digital domain for processing. In order to convert the measured voltage into the hot junction temperature, one must accurately measure temperature at the cold junction. Depending on the application, this can be accomplished using thermistors, RTDs, or silicon-based temperature sensing devices. Lastly, each thermocouple type has a high-order equation that must be computed using the cold junction temperature and the voltage measured at the cold junction. The MCP9600 is a fully integrated device that eliminates the expertise required to design this complicated temperature measurement system. The MCP9600 integrates the precision instrumentation, the precision data conversion, the cold junction temperature measurement, the math engine, and the firmware to support the 8 standard thermocouple types. Other useful integrated features are an integrated digital filter, various shutdown modes, and 4 user programmable temperature limits. Now let's take a look at the demo. So this is the MCP9600 demo board. You can see the MCP9600 right here. It's in a 5x5 QFN package. One thing to note is that there's no passive components. I mean, really the only thing on the board is the microcontroller and the 9600, and then you have a connector for the thermocouple. The board comes with a K-type thermocouple, so I'm going to go ahead and plug that in. And then if you look on the GUI, right here is where you would select the thermocouple type. K is selected, but it has all the other options available. If I want to do just a single update, I can click the Update Sample button, and it gives me a temperature reading over here in the registers. You can see the hot junction temperature, which would be the thermocouple. You can see the cold junction temperature, which would be the temp sensor on the device, the integrated temp sensor. And then it gives you the calculation of the hot junction minus the cold junction, so the delta between the two. And then it also gives you the measured value of the thermocouple in millivolts. So it gives you that value as well. And then the rest of the registers, like the status register, the sensor configuration, and the device configuration, really they relate to the different features that you can set up in the GUI. So for the demo, I'm not really going to go through those. But things to note is that you can set up the shutdown modes in here. We kind of talked about that during the presentation. You can set the resolution for both the hot junction and the cold junction. As those are, as I mentioned, programmable. And then you can also set up the filter in here under this tab. So up here in the upper left, there is a button that will allow the part to data log the temperature readings for both the hot and the cold junction. The hot is the red, and the cold junction is the blue, so the thermocouple is the red, and the internal temp sensor is the blue. So if I add heat to the thermocouple temperature, you can see it rising. And if I let it go, it should go back down. Excellent. And then down here in the bottom, you have all the features that we kind of discussed as far as the alert limits and things like that. So if I click on the binary register, you can see, I'll do alert 1 so you can see the change. But if you look at the alert 1, it's all zeros if I enable. It turns it to 1, so I can enable all the different alert features. I can set the thermocouple or the cold junction as the reference temperature, and I can change the rising and the falling edge. I can select between the two. The rising edge corresponds to an over temperature condition, the falling edge under temperature condition. I can change the polarity from active high to active low, and I can change it from a comparator to an interrupt, and then I can set my limits and my temperature hysteresis down here on the bottom. Thank you for taking the time to watch this video. For more information on the MCP9600, please visit microchip.com/MCP9600.